Hi, everybody. Good afternoon. I hope you're not sleeping. Nobody's sleeping after lunch? All right. So, my name is Aisha Ali-Gombe. I'm an associate professor of computer science at Louisiana State University. And today I'm not presenting my work, it's my student's work. Unfortunately, she's not here with us today. So, the title of our work is Disclosure Divergence Measuring Privacy Policy and Data Safety Misalignment at Scale. Now, the core of this work is disclosure mechanism, which we all know this to be how apps or the way in which apps disclose their data access practices to the end users. Now, on one end, we've talked a lot about privacy policy this afternoon, right? And I think the last speaker just mentioned that, these are overly very complex document. I'm just going to add that nobody reads. Nobody reads the privacy policy, right? And so platforms started creating this sort of a summary of supposed to be the data accesses in a developer reported format, right? And so that's supposed to be more well structured and easy to understand by users. And so for Android or Google Play, we call that the data safety level. Now, ideally, there's two different documents supposed to point to the same information, but obviously developers have to be developers, right? So there could be inconsistency where, we're not reporting the same data categories, we're meeting some kind of third-party sharing, different purposes being reported, incomplete or outdated disclosures. And so the overarching objective of this work is to quantify the extent to which these two different documents or disclosure mechanisms sort of align or potentially misalign. Now, why is this important to end users? Obviously, accuracy of these two different documents translate to transparency, and transparency helps users to make informed decision. And without that or the negation of that means, that weakens users' trust and engagement. And so with that, we designed an empirical study that seek to answer about 4 different research questions, but sort of into 3 main categories, right? So the first one is to understand the extent and the pattern of disclosure inconsistencies, and then to evaluate what sort of data categories are likely to be misaligned, and then finally the sensitivity of those data categories. And so, did somebody hack me here? I'm just going to do that. All right, so that is, okay, I think this is converted to PDF, so it's kind of messed up my slide. But anyway, so we designed sort of an analysis pipeline to kind of do this empirical analysis. And the pipeline is made up of 2 sort of components. We have the first phase, which is the data collection phase, and obviously, that is integration of different tools for web scraping, as well as, the privacy policy analysis. And so at the end of that, we got data points for about 9,000 different applications, over about 400 different data application categories. Now, out of those 9,000 data points, we found that 3,000 of those data points do not have valid privacy policy statements, or just kind of the links were broken. And so that was interesting because it was not part of our research question, but we have to kind of take that into consideration. And so they were not part of our final analysis. Then, that got into our data modeling and formulation. So here, because we got data set from 2 different, sort of disclosure mechanisms, we have to be able to normalize and structure them in some kind of unified schema. So we ended up adopting 14 data categories into 2 different operations, and then we created a binary indicator where whenever there is a disclosure, that's translated to 1. Whenever there's no disclosure for a data category, that's 0. And then we formally define some of our matrix. So consistency, we define it as where the 2 disclosure kind of agree, and then misalignment is when they disagree. Then the consistency score is our agreement. The consistency score is for an app for a given operation, and that is our agreement rate for all the data accesses within the data category for a given application. And the misalignment, again, is just the opposite of that. Now, I want to also note here that the normal consistency score is actually a naive way of computing consistency, because that could overestimate consistency. And so we adopted Cohen-Kappa score just so we can be able to get true agreement beyond agreement by chance. And so we looked at our observed and expected agreement for the consistency score to formulate the Cohen-Kappa score. And then the last part of our formulation is the sensitivity rescoring model or rescoring function, which weighs misalignment by the sensitivity of the underlying data category. And so for each operation, for each application, for each operation, it's going to have its own SRS score. And then the overall SRS score is the joint distribution for the two different SRS scores. And then we did also a weighted function for that because we want to give a little bit more weight to a sharing disclosure versus the data collection disclosure. And so this is sort of our findings, starting with research question 1. This answers the extent and the pattern of our potential alignment and misalignment. Now, interestingly, using the naive Bayes approach, you can see that alignment or consistency is about 70%, right? And the misalignment is about 30%. Now, that is not necessarily bad, right? So we're saying, 30% of our data set, have some kind of misalignment, but 70% do have some kind of alignment. Now, interestingly, we see more misalignment within the data safety level versus misalignment in the privacy policy document. And that actually fit into our presentation this morning, where potentially developers are adding more data in the privacy policy statement versus the data safety level. Now, when we look at the Cohen-Kappa score, though, things change a little bit because now we're looking at the true agreement beyond the baseline, and we can see that the consistency actually dips significantly for data sharing compared to data collection. And so that actually says, kind of like conclusion, we're seeing that, they're kind of providing diverse representation of data practices. Now, in the second research question, we're looking at the kind of data within the data category. Is it are all the misalignment equally distributed across all the data categories, or like some data categories are likely to be misaligned than others? Now, interestingly, for the data collection, we've seen that misalignment in photos and videos is kind of the top, and then followed by location and app activity, while for data sharing, more personal information, right? That's about 72%. And when we look at misalignment in DSL, we're seeing that cut across a broad range of data categories versus when we look at misalignment in the privacy policy document. Again, reinforcing that idea that we're actually putting, potentially, developers are putting more in the privacy policy document and not necessarily, everything in the data safety level. And then we also did a joint kind of distributional misalignment using cosine similarity. And again, that reinforces the idea that we see more inconsistencies in data sharing versus inconsistencies in data collection. Now, then the sensitivity risk scoring, this is sort of interesting because when we computed the SRS, and so SRS, anything below 0.3%, or sorry, 30%, that is sort of low sensitivity score, and then medium, and then high. And so we're seeing that only about 1.2% of our data set falls into that high sensitivity risk. And I think that is good for this group, even though, we want to get it to 0, but that is not overly, bad. But unfortunately, the top point there shows, even though we have very few applications in this group, they tend to have a lot of data. In fact, most of them have all the 14 data categories that have been misaligned. So, they may be a small number of apps, but they consider a significant misalignment. And then we looked at whether that also there's some kind of correlation between the app category, and we find that most of the apps within wearables and communication, they exhibit the highest SRS, but across the board, most of the apps have, kind of medium SRS. Now, we all did a little bit of qualitative analysis, which is really mostly observational. And the first one was really interesting because we looked at those 3,000 applications that didn't have a valid privacy policy document. We're like, okay, what's going on with those? And interestingly, almost about a fourth of those applications, they mentioned that they do not collect data, but they do also share data with third party. And that is actually contrary to just the description of what is data collection, by Google Play. So that was sort of like, wow, an anomaly situation. And then the next one was actually mind-blowing because this was in the Google data safety level documentation that says, if a developer categorizes a third party as a service provider, they do not have to disclose that as in the data safety level as sharing with a third party. So that means all of your analytics company and whatnot, as long as we say they are service providers, we should not disclose them in a third party. So that was interesting because we don't know at this point how much developers are taking, advantage of this loophole, but, we need to probably evaluate that more because, it's just an opportunity to not disclose. And then I will see more on the representation of third-party sharing overall compared to data collection. And so we provide some recommendation. I'm not going to go through all of that, but sort of the idea that we have in mind is if the developers will not do the good job, right? We gave them privacy policy document, they're not doing a good job. They do data safety level, they're still not doing a good job. How about if we give them some rating? We can put in consistency rating or inconsistency rating or some kind of SRS score. So that way, somebody sees like, okay, whatever you're saying is not aligning, so maybe that will help them do a good job. And then we believe that, that third-party sharing is very important, and we should not only be disclosing that, but also disclosing the names of the third-party companies. And so I'm going to leave it there. And so if you're interested in the paper, please use the QR code to scan. I don't have a poster, but feel free to talk to me after this presentation. Thank you.